Hello, everyone. Welcome to the Alluxio Structured Data Services presentation at PrestoCon. This presentation will be about how we're able to optimize query performance by decoupling Presto and the Hive data warehouse. First, a little bit about ourselves. I'm Calvin Jia, and I'm an Alluxio PMC and core maintainer. I'm joined today by Jean Peng, who is the lead developer of Alluxio Structured Data Services, and also an Alluxio PMC member and core maintainer. Here's the agenda for the presentation today. First, we'll give an overview of Alluxio and why we set out to build structured data services in the first place. Then we'll have a deep dive into how structured data services work for Presto. And finally, we'll finish the presentation with a demo. Some of you may be asking, just what is Alluxio? Alluxio is an open source data orchestration framework. It decouples compute and storage and provides an abstraction for both layers. Compute applications like Presto can access files with the semantics, latency, and throughput expected of storage, even if the underlying storage is not as fast or even providing the same APIs that Presto wants to use. But while the data orchestration layer enables flexibility and compatibility, performance is often the most compelling reason for using something like Alluxio. Let's take a look at how Alluxio can improve performance for Presto. Alluxio accelerates the performance of Presto by making file reads faster. Scans of data in memory are an order of magnitude faster than on disk, which are then an order of magnitude faster than reading from a remote storage like S3 or remote HDFS. By acting as a data cache, Alluxio improves the I/O speed of Presto, especially in cases where the underlying storage is remote or otherwise slow. An often overlooked aspect of performance is metadata performance. Presto queries can request a huge number of metadata operations, especially when the query parallelism is high. Alluxio can provide latency an order of magnitude less than object storages in the cloud, and with much less variance. In addition, Alluxio metadata operations are free, as opposed to metadata calls to cloud storage, which, unlike data transfer, even same region metadata operations can still incur costs. However, despite these performance improvements, a common ask from our users was to further improve the performance of OLAP workloads on Alluxio. And to do that, we realized we needed to go beyond files. By just managing file access, Alluxio could not impact the portions of the query which were slow. Here are some examples. If the Hive Metastore was overloaded and it just had very high latency, all the queries would just take a hit in performance. If the ingested data format was unfriendly to querying, like a CSV format, the query plans would not be able to take advantage of many optimizations and therefore become inefficient. Similarly, if the ingested data had tons of partitions and small files, even if your data format was something like Parquet, it still wouldn't be able to efficiently serve the data for the query. To address these problems, we designed Alluxio Structured Data Services, a major new component of Alluxio. Jean is the lead developer of the module, and he will describe how we tackled these problems and the benefits of going beyond the file level in Alluxio.
Thank you, Calvin. I'm Jean, and I will be talking about the Alluxio Structured Data Services. First, before talking about Alluxio Structured Data Services, I will talk about a little background on the typical environment with Presto. So here is a typical environment. We have Presto with its Hive connector, and it's communicating and interacting with the Hive Metastore and the storage in order to service the queries. This is a pretty simplistic view, but in reality, a lot of environments could look something more like this, where there are a lot more components in the ecosystem. So it's not just Presto and the storage, but there may also be other computation frameworks like Spark and Hive that is also accessing the storage as well as the Hive Metastore. In addition to that, there could be other types of applications that are ingesting data into the Hive warehouse, communicating both with the storage and the Hive Metastore. So there actually could be many different components to the entire Presto and Hive environment. So with all of these potential components, there are some inefficiencies that might be possible. One might be just an overloaded or a slower Hive Metastore when being accessed by many different applications. Another could be that there are unoptimized file formats. For example, CSV is typically slower than other file formats such as Parquet or RC, which are more optimized for analysis. There could also be inefficient table organization. And one example of that could be if there are just too many directories or too many small files, like that could negatively impact the query processing. And also, there may be an inability to be able to update existing applications and how those applications are writing the data in the Hive warehouse. So there might be an example of like a legacy application or a different organization that is essentially ingesting data into the Hive warehouse, and that is not, that you are not able to modify how that application is written. So because of these potential dependencies, there's really like a really strong dependence from Presto to the Hive warehouse, both to the Hive Metastore and the storage. As I mentioned before, whether the files are in a specific format or organized in a specific way, or being accessed by the Hive Metastore, Presto is technically dependent on those components. So there isn't very much flexibility. So can we unlock this type of dependence? Well, in order to unlock the potential, we could use data orchestration. And with data orchestration, it is able to provide decoupling of the compute from the Hive data warehouse. So in this example, it would be decoupling Presto from the Hive data warehouse. And this also can further enable compute optimized data access with data orchestration. So specifically with Alluxio data orchestration, this is what the environment will look like. Presto would communicate with Alluxio, and then Alluxio would help manage the access and the access to the Hive Metastore as well as to the storage. And this layer in between Presto and the Hive warehouse really helps decouple the two components, as well as be able to provide compute optimized data access for Presto. And so this is a simple overview of how Alluxio data orchestration can fit in the ecosystem. So the types of benefits of data orchestration are many. So here is an example of sort of the storage systems on the left, which is the Hive warehouse, and the SQL frameworks on the right, which is Presto. And being able to bridge this gap is the Alluxio data orchestration. And before structured data services, Alluxio already provides some of these benefits, such as caching and unified interface and namespace. These benefits already are there with Alluxio. But with structured data services, we're able to provide additional benefits, such as schema-aware optimizations, compute-optimized formats, and ultimately physical data independence. What that means is the application, like Presto, is not tied down to the physical representation of that data in the Hive warehouse, and there can be some sort of difference in how the application can access that data. So next, I will go over what Alluxio structured data services are and the different components of it. So in this diagram, we have the storage system files and data on the left, and then the SQL engine, such as Presto, on the right. And everything in the middle here is what are different components of the Alluxio structured data services. So one component of SDS is the transformation service. And this helps transform the data that's stored in the warehouse into a format that is more optimized for the compute engine. We also have structured data and metadata. And what this component is for storing and managing the data and metadata that is relevant for the structured data. And this could include both the payload as well as like the metadata such as schemas and column information. And lastly, we have the access layer, which is the structured data client. And this helps, read the data as well as the metadata that is being managed by the Alluxio SDS. So as I mentioned before, this is the typical Presto environment, and this is also the typical environment. This is the target environment for Alluxio SDS. So the new components. First is the Alluxio connector. This is the Presto will now use the Alluxio connector in order to communicate with the various other services of Alluxio. There's also the Alluxio caching service, which helps bring the data closer to the application, closer to Presto, and accelerate the data access. We also have the Alluxio catalog service, which helps manage the metadata for tables and columns and rows. And we also have the Alluxio transformation service, which is utilized for transforming the stored data in the warehouse into a format and organization that is more optimized for Presto. So for the Alluxio catalog service, its main functionality is to manage the metadata for structured data and for the tables. And the main concept here is the under database concept, which is an abstraction of other types of catalogs that can be hooked into Alluxio catalog service. Today, we have two types of UDBs. One is the Hive UDB, which will interact with the Hive Metastore, and we have the Glue UDB, which will interact with the AWS Glue. And with the catalog service, this really affects some of the benefits of the catalog service is to be able to provide schema-aware optimizations, and also improves and simplifies the deployment of Alluxio with Presto. Since now, restarts and reconfigurations are no longer required, we just need to point to the catalog service, and the Alluxio catalog service will do the appropriate thing to map it to Alluxio locations for Presto. We also have the Alluxio Presto connector, and this really helps Alluxio have a tighter integration with Presto. And it's a new plugin connector based on the existing Presto Hive connector. And the source code has actually been merged into both Presto SQL and Presto DB source code. And so they are available in these versions of Presto SQL and Presto DB. And lastly, we have the transformation service. And ultimately, the goal for the transformation service is to transform the data so that it is compute optimized, and that which may be independent from the storage optimized format. And those could be different, which is why it is important for some transformations. Here's one example transformation that is available, which is the coalesce transformation. This is where it takes many smaller files and and coalesces it into fewer larger files. And this is typically more efficient to process when there are fewer larger files than too many small files. And another transformation that's available is the format conversion. And in this example, we have a CSV to Parquet format conversion in the transformation service. And this can be helpful because Parquet is more efficient to process than CSV is. So this can also help with helping the data be more compute optimized. So next I'll go into a short demo of how this works. So for the demo setup, we have two isolated clusters, and each of these clusters are the same size. The only difference is that one of the clusters has Alluxio SDS and the other cluster doesn't. So in one cluster, we have Presto and the Hive Metastore and S3 data. And in the other cluster, we have the same setup with Alluxio SDS. And we have some sample data with TPCDS on S3. And the one difference here is that some tables in this sample data set has many CSV files in it. So we want to show how unoptimized organization and formats can be transformed into be more optimized, more compute optimized. So here is the demo. So on this left-hand side, this is the cluster that has Presto and Alluxio. And on the right, this is the cluster that has Presto and just Hive, Hive Metastore, no Alluxio. And so the first thing we will do is simply just attach the data, attach the Hive Metastore to Alluxio. And what that is doing is making a connection and making an association for the catalog in order for the catalog to be aware of the Hive Metastore. And so then we can also list the tables in the Alluxio catalog, and these are the TPCDS tables. And next, we can even see it in Presto. We can see the same tables in Presto. And so right now, this Presto show tables command is communicating with the Alluxio catalog service and retrieving those table names. And we can also just do a simple small query just to see that it's grabbing the data. So this is also the Presto is going through the Alluxio connector to communicate with Alluxio to get that data and the metadata. Now, as I mentioned before, some of the tables are very inefficient, meaning there are too many small CSV files. So one of those such tables is the store sales table. And what we just did here is we will initiate a transformation of that table in the Alluxio structured data services. So once that is kicked off, we can check out the status of that job. And right now it is running. It'll take about 30 seconds. So while that's happening, we are going to check out the other cluster, which just has Presto and Hive, and just look at the data there. So we connected to Presto and Hive. We can also do show tables here, and we can also do a simple query from Hive. And what we're going to do is we're going to run one of the TPCDS queries. And this query is just one of the queries, and it does access the store sales table, which has a lot of small CSV files. And with this query, it's actually going to be accessing the S3 files directly because Alluxio is not involved. And so as you can see, it finished its access that table, the store sales table with many CSV files, and it took about 21 seconds. If you go back to Alluxio cluster here, and then look at the status of that job, we can see that it is completed. We can also take a quick look at the files that are there. And so here we have about 1.5 gigs of data, and actually none of it is cached in Alluxio yet. So what we'll do now is run that query on the Alluxio cluster after it's been transformed. So now we're running that query in the Alluxio cluster, and this is now going to be using the transformed data in order to satisfy the query, and it got faster, and it took about 8 seconds. So the Hive query by itself took about 21, 22 seconds. With the transformations, it took 8 seconds. And then if we take a look at the Alluxio listing again, here we can see that now all the data is cached in Alluxio. So when we run it one more time on the Alluxio cluster, it's now going to read the cached and transformed data. And it was faster, and it took about 4 seconds. So this was a quick demo, like how the Alluxio SDS components work. And then going back to the presentation. Yeah, so here's a quick summary of the demo that we have. We attached the Hive database to the catalog, and from then on, it served all the information to Presto through the Alluxio connector. And so Presto without Alluxio took about 22, 23 seconds. With just the transformations, it took about 8 seconds. And then with the transformations and caching, it took about 3 to 4 seconds. So this is just a simple example of how the structured data services can help with the Presto deployments. So lastly, we have future work for the structured data services. We have, and most of these are actually from the community itself. And so we have new UDB implementations. We did just recently add the AWS Glue implementation. So that is there. And there are also additional ones that we have been discussing. We are also considering additional conversion formats such as JSON, converting JSON. We're also looking into some DDL DML workloads. Right now, only the read-only workloads are supported. And we're also looking at Arrow for some additional optimized structured data APIs. So yeah, this has been available for a few versions. It's there in 2.3. You can check it out, and also always, providing feedback is very important to us. So you can always talk to us in our Slack channel, or report any issues in our GitHub issues tracking. So that is it. Thank you very much.